If you're running Azure Virtual Network peering across regions and wondering why your application feels sluggish, I'm about to show you the 3 optimization techniques that cut our clients' cross-region latency by 40% last month.
Hey everyone, great to be back on the CloudCast.
Welcome back to the Network Ninja CloudCast. I'm Marcus, and today we're diving into something that trips up even experienced Azure architects. We're talking vnet-peering bandwidth and latency, specifically when you're spanning multiple regions.
So I've been setting up vnet-peering between our East US and West Europe deployments, and honestly, the performance has been inconsistent. Sometimes it's fine, sometimes it crawls. What's actually happening there?
Perfect example of why this matters. Here's what most people don't realize. Azure vnet-peering doesn't have a hard bandwidth cap in the traditional sense, but your throughput is absolutely constrained by the VM SKUs on both ends of the connection. If you're running a standard D2S v3, you're looking at an expected network bandwidth of around 1000 megabits per second. Now, Azure can let you burst above that temporarily using network burst credits, but sustained throughput will settle around that expected value. That's not a peering limit, that's your VM's network allocation.
Wait, so the bottleneck isn't the peering connection itself, it's the VMs?
Exactly right. Azure's backbone network between regions can handle massive throughput, but your individual VMs have what Microsoft calls expected network bandwidth based on their SKU. You can find these exact numbers in the Azure VM sizes documentation. A standard D8S v3 gives you 4000 megabits per second expected, while a D64S v3 maxes out at 16,000 megabits per second. So step 1 in optimization is right-sizing your VM SKUs for your actual network requirements.
Okay, that makes sense. But what about the latency piece? Even with bigger VMs, I'm seeing 80 to 100 milliseconds between East US and West Europe.
And that's in the expected range for that distance, though it's worth understanding why. Let me give you an analogy. Think of cross-region traffic like shipping packages internationally. You can upgrade to a bigger delivery truck, that's your VM bandwidth, but the truck still has to drive the same distance. The speed of light through fiber is roughly 200,000 kilometers per second, and East US to West Europe is somewhere between 7,000 and 8,000 kilometers when you account for actual submarine cable routes. That gives you a theoretical minimum of around 35 to 40 milliseconds one way, so 70 to 80 milliseconds round trip just from physics. Add in routing hops, encryption overhead, and network equipment processing, and you're at 80 to 100 milliseconds realistically. If you're consistently seeing latency much higher than that range, it might be worth investigating other factors.
So physics is actually the limiting factor there, not Azure's infrastructure?
Precisely. Now here's where optimization technique number 2 comes in. You can't beat physics, but you can reduce how often you need to make that round trip. This is where Azure Global vnet-peering combined with strategic resource placement matters. If your application in West Europe frequently queries a database in East US, every single query pays that latency tax. The fix is implementing read replicas using Azure SQL Geo-replication or Cosmos DB multi-region writes, so your West Europe app reads from a local replica.
That's smart. So instead of optimizing the pipe, you're reducing dependency on the pipe altogether.
Exactly. Now technique number 3 is about what happens when you do need cross-region traffic. Enable accelerated networking on your VMs. This bypasses the host CPU and uses SRIF to give your VM direct access to the physical NIC. For supported VM sizes, and that's most D-Series, E-Series, and F-Series VMs, you'll see significant latency improvements for the Azure side processing. Microsoft documents this as reducing VM to VM latency from around 150 microseconds down to about 25 microseconds. Now, for cross-region traffic where you're dealing with tens of milliseconds from distance, that microsecond improvement is a small percentage. But for latency-sensitive applications, every bit helps, and for traffic within a region or data center, the improvement is dramatic.
How do I actually enable that? Is it a checkbox somewhere?
In the Azure portal, when you create or modify a VM, go to the Networking tab, and there's an Enable Accelerated Networking toggle. For existing VMs, you'll need to stop the VM first, enable it, then restart. You can also do it via Azure CLI. The full command looks like Oz Network NIC Update. Then you specify the NIC name with name, your resource group with resource group, and then Accelerated Networking True. Make sure you have all those parameters or the command won't work.
Got it. So what are the common mistakes you see people making with cross-region peering?
The biggest one is assuming global vnet-peering is free. It's not. You pay for data transfer, and the pricing varies by zone. For intracontinental peering, like East US to West US which are both in Zone 1, you're looking at around 1 cent per gigabyte. But for intercontinental peering like your East US to West Europe scenario, that jumps to 2 to 5 cents per gigabyte depending on direction and specific regions. Always check the current Azure pricing calculator for your specific region pair, because these rates do change. I've seen teams rack up thousands in unexpected charges because they didn't realize their chatty microservices were constantly crossing regions. Always check your peering traffic in Azure Cost Management and set up budget alerts.
That's a painful lesson to learn from a bill. Any other gotchas?
Yes, don't forget that vnet-peering is non-transitive by default. If net appears with met-b, and met-b peers with met-c, meta cannot reach met-c through b unless you explicitly configure transit. Now, you have several options here. You can use a hub-spoke topology with Azure Firewall or a network virtual appliance as the transit point. But there are also simpler options depending on your scenario. You can configure vnet-peering with allow gateway transit and use remote gateway settings if you have a VPN or ExpressRoute gateway. Azure Virtual WAN is another option that handles transitive routing natively. Or you can set up user-defined routes to enable transit through a hubvnet. Pick the approach that matches your complexity and budget requirements.
Okay, let me make sure I've got this. First, VM SKU determines your expected bandwidth ceiling, not the peering connection. Second, reduce cross-region dependency with geo-replication instead of trying to speed up the connection. Third, enable accelerated networking to cut Azure-side latency overhead, especially for intra-region traffic.
Perfect summary. And my pro tip is to use Azure Network Watcher's Connection Monitor to baseline your actual latency and throughput before and after these optimizations. Real data beats assumptions every time.
This is super practical. I'm definitely checking our VM SKUs and enabling accelerated networking today.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone wrestling with Azure networking performance.
Thanks for watching the Network Ninja CloudCast. See you in the next one.